Hello, and welcome to today's tutorial. Today, we are exploring the for loop in SCL. We will be building upon our previous warehouse storage project, but don't worry if you missed it. We are starting with the core principles from the very beginning. Imagine a storage system with 100 shelves, numbered from 0 to 99. In our last session, we created a manual system. If you select shelf number 3 and press Put In, that shelf value becomes 1. If you press Take Out, it becomes 0. But here is the challenge. What if you have items scattered across dozens of different shelves and you want to clear everything at once? Manually clicking every shelf is inefficient. This is where the for loop becomes essential. We want to create an empty storage button that, when pressed, automatically sets every single shelf back to 0. In SCL, unlike other PLC languages, the code isn't broken into networks. It is one continuous block of logic. To stay organized, we use 2 forward slashes to create comments. These lines turn green and are not executed by the PLC. They are just notes for us. Let's label our new section, Empty Storage Code. To start, we use the for to do instruction. The syntax looks like this. For, followed by a counter, then an assignment, a start value, a to value, and finally, do. In our case, our start value is 0. Our end value is 99. The counter is a variable that automatically increases by 1 during every iteration of the loop. For the counter, it is best practice to use a temporary variable. This is the most memory efficient option. We will name it empty counter. When choosing a data type, it is important to use a compatible integer. A short integer, or sint, is perfect here. It is an 8-bit type that covers our range up to 99 easily. Now, let's write the instruction inside the loop. We reference our array called shelves. Instead of putting a fixed number in the brackets, we insert our empty counter variable. The code reads shelves bracket empty counter bracket assignment false. In the first cycle, the counter is 0, so shelf 0 is cleared. In the next cycle, the counter becomes 1, clearing shelf 1. This continues until the PLC reaches 99. We don't want this loop running constantly. We only want it to trigger when we press a button. To do this, we wrap the entire loop inside an if statement. The logic is, if empty storage button is true, then execute the for loop. It looks at that specific shelf and applies our instruction, set value to false. Imagine we want to fill shelf number 5. First, we set our selected shelf variable to 5 and trigger the put in button. In our data block, you can now see that shelf 5 is set to true. It is no longer empty. Now, watch what happens when he activates the empty storage button. The moment that button is pressed, the if condition is satisfied and the PLC enters the for loop. The counter starts at 0 and moves rapidly through the array. When the counter reaches the number 5, it looks at that specific shelf and applies our instruction, set value to false. Even though we only manually filled shelf 5, the loop checks every single position from 0 to 99. As a result, shelf 5 is reset to 0, along with any other shelf that may have had data in it. The entire storage system is now clean and ready for new entries. Even though we only manually filled shelf 5, the loop checks every single position from 0 to 99. As a result, shelf 5 is reset to 0, along with any other shelf that may have had data in it. The entire storage system is now clean and ready for new entries. Watch out for when using loops. First, array limits. If your array ends at 99, but you tell your loop to go to 100, the PLC will try to access a memory area that doesn't exist. This results in an area length error, and your PLC will go into a stop state. Always ensure your loop limits match your array size. Second, cycle time. Every time the PLC runs its program, it must complete the entire loop. If you create a loop that runs too many times, the processor will spend too much time in that single cycle. If the cycle time exceeds the watchdog timer, for example, 150 milliseconds, the PLC will crash into an error state. Use loops considerately. That covers the basics of the for to do loop in SCL. It's a powerful tool for managing arrays and repetitive data. In our next video, we will look at the while do loop. If you found this helpful, please like and subscribe. Thanks for watching, and I'll see you in the next lesson.